In this video, we are going to be looking at artificial sweeteners. Understand that the concepts discussed in this video are not discussed in the textbook. This is supplemental material that it will be required for the final exam. So, artificial sweeteners were developed in industry in order to have products that will not be able to be metabolized in the body, but it can still detect sweetness according to the receptors that we have in our mouth. So we are just going to talk about a few examples of artificial sweeteners, and I want to illustrate their use, their structure, and also some of the problems that arise from the use of artificial sweeteners. So the first one that I'm going to talk about is sucralose. Okay, and you may not know sucralose, but you may know the product Splenda. That is the marketing name. Now, understand that when it comes to sucralose, sucralose is actually made from sucrose, and it is made by replacing some of the hydroxyl groups that are in sucrose, meaning table sugar, which with chlorine atoms. How many chlorine atoms, you may ask yourself? Well, there's 1, 2, 3. So the replacement of those 3 hydroxyl groups by chlorines was what gave rise to sucralose. So Splenda is one of those things that is actually utilized often, and now we have products in which Splenda can be used for baking. Splenda can be used just for normal sweeteners, but the use of Splenda has not been studied in humans yet. But so far, animal models have shown that sucralose causes liver and kidney damage when used in very high amounts. Now, this is one of the things that I want to specify. I know that some students will be using these artificial sweeteners. I'm not trying to scare you away from using them. I'm just giving you the reality of them. So at least you have an educated educated information on the use of artificial sweeteners. When these experiments were done in animal models, understand that these animals are going to be exposed to really high amounts because it depends on their size and weight and how they determine this exposure. But the most concerning thing is that there are people out there that consume these products in very high amounts, but there's no data out there to tell them of the repercussions of using these artificial sweeteners in high amounts. Let's move on to the next one, which is aspartame. When it comes to aspartame, understand that they are aspartame is marketed as NutraSweet or equal, and understand that this artificial sweetener is known as a non-carbohydrate sweetener because when we look at the structure, aspartame is actually a dipeptide. It is made from linking aspartic acid and phenylalanine. It's just that at the end of the molecule, as you can see, we have a metal ester. Okay, so the carboxy terminus of our dipeptide, now it was modified by a methyl group. Now, similar to what has been observed in animal models with sucralose, when people have, when animals have been exposed to high levels of aspartame, not only the kidney effects or the liver effects have been observed, but also it has been documented that aspartame causes addiction. So you will be craving that aspartame taste. For those of you that drink Diet Coke, that sourness and that bitterness that is at the end of, tasting those products, that's where the aspartame comes from. The next artificial sweetener that I'm going to talk about is saccharin. So saccharin is marketed as sweet and low. This is another non-carbohydrate sweetener, okay? And understand that these artificial sweeteners that I have talked about, sucralose, aspartame, and saccharin, all three of them are known as no-calorie sweeteners because they don't give any food energy. What that means is that when you consume them, the body doesn't turn it into ATP. Now, understand that when it comes to saccharin, it's actually 300 to 400 times as sweet or sweeter than sucrose, but it has a bitter or metallic aftertaste, especially when it's in high concentrations. And as you can see in the bottom of the slide, this is the structure for saccharin. So, how sweet is sweet? I just wanted to illustrate a table which I have taken from a different textbook, in which here in this experiment it was associated to give particular monosaccharides or even disaccharides a sweetness level. So remember, we are going to be comparing everything to sucrose, and sucrose in this list is right here. So sucrose is going to have a value of 100, and we are going to compare everything relative to this. So as you can see, most monosaccharides and disaccharides actually are less sweet than table sugar. All of them except for fructose. Fructose is the only monosaccharide, and then fructose is actually fruit sugar. Is the only monosaccharide that is actually sweeter than sucrose. Now, if we compare to sugar alcohols, and again, sugar alcohols are also sweeteners. If we compare, for example, sorbitol, maltitol, or xylitol, only xylitol is as sweet as table sugar, okay? Now, if we look at specifically the artificial sweeteners, it says non-carbohydrate, but remember that sucralose is a carbohydrate derived sweetener. Understand that when we look at the magnitude of how sweet they are compared to table sugar, aspartame, as you can see, the unit is going to be 18,000. Saccharin is 45,000 and sucralose is 60,000. So all these artificial sweeteners, okay, and remember, sucralose is the only one that is carbohydrate derived. Aspartame and saccharin are not. They are much, much sweeter than table sugar. When these products were invented, they were created such that people will use them in small amounts. And for example, diabetic patients, because they already have problems with managing their glucose, because, for example, it could be that they're not responsive to insulin. These products were created so they'll be able to consume something that will be detected as sweet in very small amounts, but because it's not going to be creating fluxes in glucose, then they could be consumed. But one of the things that actually recently was found out is that some of these artificial sweeteners are affecting glucose levels, and they actually, if consumed in certain amounts, they are actually giving spikes in glucose. Again, no human data has been recorded. This is based on animal models, but it is something to always be conscious about when you decide to use these products.